Hello everyone. Today we're going to be looking a little bit more in depth at tectonic plates. And specifically we're going to be looking at the point where two tectonic plates are touching one another, something that we call plate boundaries. And we're going to start these notes by looking at some definitions that are going to be important as we go through the rest of this video. First, a plate boundary is a location where two separate tectonic plates meet, or where they're touching. Divergent boundaries are where two plates move away from each other. Convergent boundaries are where two plates move towards each other. And transform boundaries are where two plates slide past one another in opposite directions. Let's take a closer look at divergent boundaries. At divergent boundaries, the two plates, as we said earlier, are moving apart. They're moving away from each other. One plate is moving to the right or left, and the other is moving in the opposite direction. Right in the middle of that divergent boundary, magma rises through a mid-ocean ridge. That's what they call it if it's underwater. If this divergent boundary is on land, it moves through a rift valley. And the rising magma, that magma that's rising up right through here, helps to push the two plates apart. So again, at divergent boundaries, we have these convection currents. You can see those convection currents operating right through here. Again, convection currents are playing a major role in tectonic plates. The plates are following those convection currents around, and then right up through the middle we have magma coming. There's some key characteristics that all divergent boundaries have in common. One of those would be mid-ocean ridges. So again, if it's underwater, we're going to see a mid-ocean ridge, which really looks like a mountain range. It's a volcanic mountain range running through the water where all that new magma is coming up. If it is on land, we get some rifting and rift valleys. That's if the divergent boundary is on land. And then perhaps most importantly, this is the site of new oceanic crust formation. So if we have a mid-ocean ridge, that causes the ocean to get bigger. We're laying down more oceanic crust, and the ocean is spreading apart. If this happens on land, eventually that oceanic crust will spread apart to a point where water can flow in over it, and it might create a new sea or a new ocean. So either way, it's always making new oceanic crust. It does not make new continental crust. Attached to this presentation is a little video that will hopefully help explain divergent boundaries. So we can see the heat is rising up, the mantle is migrating, and then we get magma pushing up through the lithosphere and through the crust. See that here, and eventually that causes the crust to spread in opposite directions. So the oceanic crust is spreading apart at our mid-ocean ridge. And this is very slow. It's only moving about 3 to 10 centimeters a year, which is pretty close to the rate that your fingernails grow. Next, we're going to be looking at transform boundaries. And at transform boundaries, both plates are sliding past each other in opposite directions. So as you can see here, one plate is moving this way and the other plate is moving in the opposite direction. Here's a picture of a transform boundary, and what you're seeing is a dried up riverbed, and this used to be a single connected structure, but this transform boundary has slid the riverbed away from where it used to be, and that's why it looks like it's broken. Just like with divergent boundaries, there's certain characteristics that transform boundaries tend to share in common. The first is a fault line. So this is a structure that you can often see on the surface of the Earth, and it just shows where those two plates have been sliding past one another at this fault line. And then the other thing that we see pretty commonly are earthquakes, because sometimes those plates get stuck and the pressure builds up over time, and when they release suddenly, we get an earthquake. You will be learning more about earthquakes in the black diamond section of this unit, but there's another video here that helps to show what is happening with transform faults. So again, transform faults come because of two different divergent boundaries. We see a divergent boundary here and a divergent boundary here, and that causes the plates to slide past each other in opposite directions right here. One of the main transform faults that we see is in California. It's called the San Andreas Fault, and it's moving Los Angeles towards San Francisco. All right, for our next type of plate boundary, we're going to be looking at convergent boundaries. And once again, at convergent boundaries, convergent boundaries, both plates slide towards each other. The plates are moving towards each other, and eventually they collide. There will eventually be a collision. And depending on the type of crust that we're dealing with, whether it's oceanic or continental, different things are going to happen due to that collision. So let's take a look. So again, there's three different types of convergent boundaries depending on the type of crust. You can have a situation where oceanic crust collides with another piece of oceanic crust, so oceanic convergent boundary. You can have oceanic crust collide with continental crust, and that would be an oceanic continental convergent boundary. Or you can have continental crust collide with another piece of continental crust, and that's what's called a continental convergent boundary. And we're going to see different characteristics with each type of boundary. Let's take a look at those in more detail below. At oceanic convergent boundaries, there's certain type of characteristics that we see. So at this type of boundary, you would expect to see trenches first and foremost. And a trench is a feature where as this plate is subducting, so we have this first plate subducting over here going down into the mantle, it bends the other plate with it. So the plate on the right is getting bent, and you can see that it dives down as well. And these trenches create some of the deepest features in our oceans. You might have heard of Mariana's Trench, which is the deepest trench we have in any of our oceans. But anywhere there is a subduction zone where oceanic crust passes underneath another piece of crust, we get a trench. And then at oceanic convergent boundaries, we also get volcanoes forming, but these volcanoes form underwater, so we end up with volcanic islands. There's a rule for which plate is going to slide under, for which plate is going to subduct, and the older plate, so the plate that's made of older rocks, will always subduct under the younger plate. And the reason why this happens is the older plate is more dense than the younger plate. It's had more time to cool and gain material. So the older plate is more dense and it sinks underneath the younger plate. And then we get those volcanoes showing up in the younger plate. The next type of convergent boundary we're going to explore is the oceanic continental convergent boundary. Again, that's where an piece of oceanic crust over here collides with a piece of continental crust. And again, at this boundary, we still see trenches. So there is trenches here as well for the exact same reason that we see trenches in the oceanic convergent boundary. You can see the trench here. We also get volcanoes, But this time, since the volcanoes are forming over, or under, I should say, continental crust, we don't get volcanic islands. We get volcanic mountains. And again, the oceanic plate is always going to subduct under the continental plate. Continental crust is less dense than oceanic crust, so it's always the oceanic crust subducting. And then the subducting plate causes magma to form, which builds our volcanoes. Then the last type of convergent boundary is a continental convergent boundary. And when two pieces of continental crust meet, we get folded mountains. These are not volcanic mountains. These are just large mountain ranges from the crust coming together and folding, and we get some of the most powerful earthquakes happening at these as well. In fact, you would get earthquakes at all three types of convergent boundaries, but often some of the most powerful ones are happening here. Again, both colliding plates here are made of continental crust. And those are not dense enough to ever submerge. They are less dense than oceanic crust, so they cannot subduct into the mantle. Instead of subducting and going down, these plates just fold up and produce mountains. That's going to do it for our notes on plate boundaries. As always, if you have any questions, please ask Mr. Tanner. Thanks. Have a good one.